So for this, we have that some college students use credit cards to pay for school expenses. For this population, the amount paid is normally distributed with a mean of $1,615, which seems like a lot to me, and a standard deviation of $550. First, we want to find the probability that a randomly selected college student who uses a credit card to pay for school-related expenses paid less than $1,400. And then we want to find the probability that the mean amount paid in a sample of 25 students was less than $1,400. So the first thing we have to understand here is our first case isn't actually anything special. It's not anything really different from what we've seen so far. That's just the sort of thing we got in 5.2. If we want to find the probability that a single student paid less than $1,400, that's just a pretty standard normal CDF computation, where what we put into there is our lower boundary amount, something in there like -1 E99, because that's a pretty big number we're dealing with, 1,400, that mean of 1,615, and the standard deviation there is 550, which would get us a probability of about 0.3483, given that distribution, given that shape of the situation where we're just trying to find it in terms of a single value. On the other hand, for our second case, if we want to find the probability that the sample mean is less than 1,400, this is something more like what we've been seeing here. This is something more in terms of sample behavior, more in terms of the central limit theorem, where in this case 25 is not enough technically, but we are assuming normality to begin with. So the central limit theorem applies, and because I'm short on space, I'm not going to write out exactly what you put in the calculator again, but you would go in there, you'd have that same sort of up to 1,400 idea, where you would be looking at the mean of sample means of 1,615, but now the standard error would be that value 550 divided by the square root of 25, or 5. But the point is, you'd have a lot less variation. You'd have a much thinner distribution of values. And as a result, the probability here would be much smaller. Only about 0.025, it's not a 0, bad copying, 6. So you go from about a 35% chance to less than 3% by talking about mean behavior instead of single value behavior. Again, it's important to bear in mind here that when we're looking at these means, because we're taking into account a lot more information every time, we're taking into account a lot more pieces, there's a lot less variety, and as a result, these changes, these ranges, get much more unusual. So these probabilities tend to get much smaller. But that's really all we're going to see here for 5.4. You might get some stuff in the homework about looking for inverse normal type values. You'll get that on the worksheet as well. It's all about just getting used to these probabilities and these values. And next week, that is, we're going to move into section 6.1. We're going to move into chapter 6, where we're going to take this stuff and use it to try and make some estimates. We're going to talk about things called confidence intervals, but those are later on problems. For now, get some practice with this stuff, and I'll see you then.